All right, so we are now moving on to section 7.3. This section is going to be broken up into 3 different videos. The first video that we're going to work on now is we're going to write and evaluate logarithmic expressions. Right, that's the first video. The second video is going to be graphing logarithmic functions. And then the third video is going to be doing logarithmic transformations. All right, you'll see that third video is exactly what we did in the past. It's everything that we've learned before. So the third video should really be an easier video because it's everything that you guys have already learned. All right, one of the things that you need to know, especially for the second video, but for this one as well, is that exponential functions, y to the bx power, so that's an exponential function because our variable x is in the power, that is 1 to 1. And what does that mean that it's 1 to 1? That means that it is a function. And it also means that its inverse is a function because whatever we substitute in, remember when we did 1 to 1, it was f of f inverse of x is equal to x. So that means that we have a function for both our regular function and our inverse. So the inverse of this, x is equal to by, where we switch our x and our y position, is a function. Right? And it's important to identify or to be able to understand that when we're going to graph. And the way that we write our inverse and the way that we would solve for this, because remember we switch our x and our y and then we solve, is the inverse of the exponential function is y is equal to log base b of x. Right? And we'll go over that momentarily. Right, so the first thing that we're going to do is I want to ask this question to you. How many times would you have to double $1 before you had $8? Right, so I want you to pause this video for a few seconds and really think about that. All right, so hopefully you paused it for a little bit, but let's go through this. So how many times would you have to double $1 before you had $8? So first, we have $1. And then if we double that, the next time we then would have $2. And then if we double that, we then will have $4. And then if we double that, we'll then have the $8 that we need. All right, so now, what I want you to think about for a second, though, I'm going to finish writing this out. All right, so now when you're doing this, here we only have $1, here we have 2, here we have 4, and here we have 8. So I want to first come up with an equation. So now we know that we have to double it 3 times. All right, it'll be the third time we double because here's doubling it once, here's doubling it twice, and here's doubling it 3 times. But let's come up with an equation for this. The first one we had 1, 2, 4, and 8. Well, 2 raised to the 0 power is 1. 2 raised to the first is 2. 2 squared is 4, and 2 to the third power is equal to 8. So what this equation or this question that's happening when we're doubling something, it's 2 raised to the x power is then equal to y. Where this represents that we're doubling something, and this says how many times we're doubling it, and this tells us what our final answer would be. So this question, if we were doing this algebraically, would 2 raised to what power is equal to 8, and x would then be equal to 3, which is what we did here drawing out. Now the issue with this, where it's not always able to be doing it mental math, is what happens if you're asked, well, how many times do we have to double $1 to get 512? So we know that doubling $1 is going to be represented by 2 to the x power is equal to y. So then we're asking 2 to what power is equal to 512? That could be a real pain to solve. However, we know that if we can do the inverse operation, we can solve for x. And the inverse operation of an exponential equation is called a logarithm. All right? A logarithm is the exponent to which a specific base is raised to obtain a given power. So what we will have to do then is we will have to rewrite this as a logarithm. And we know that the logarithm is the inverse to exponential equation. So you might ask yourself, well, how do we rewrite this as a logarithm? So in order to do that, we have this picture here. All right, so here is our exponential equation. B raised to the x power is equal to a. Now remember, B stands for base. And if you notice, the b then gets written underneath of our log. And the way that we read this is log base of b. So the base never changes. When we have our logarithm, it's still a base. It's just written underneath of our log at the bottom as a subscript. Whereas as an exponential, it's written to raise to the power. And then here, what our power is in our exponential is now going to be what it's equal to, because remember, it is its inverse operation. So we want to then change our x and our y, so our x goes from the power to what is equal to. So our power then gets written as what it's equal to, and then what our y value was once, now gets written with our logarithm. So we just change the base is still the base. It's written as the subscript in the logarithm. And then the x and our y change its position. So once was what part of our exponent or part of our equation is now our solution. And it makes sense because if it's its inverse, we know that we have to switch its positions. They switch where they're at. All right. So now let's go ahead and do a couple problems of rewriting exponential equations as logarithms. So here my base is equal to 10. So it will be log base of 10. So now what I was equal to once was 100. So that is part of my logarithm. And my power is now going to be my solution. So log base 10 of 100 is equal to 2. For this one here, my b is then equal to 3. So I know it's going to be log base 3. Once again, what was equal to in my exponential is now part of my equation, because think about it, inverses switch their position. And what was now my equation, or part of my exponential, is now what it's equal to in logarithm. Right? So that is how you rewrite. Now, when you're doing this, sometimes it's very important to be able to do this. Now, for this one here, what is the value of log base 8 of 32? You can plug this into a calculator, and I'll show you guys how you can do that later on. But for now, we can solve this algebraically and by hand. So what we will need to do for this first is take its inverse. So we need to rewrite this as an exponential equation. So that's our base, 8. So we have 8 as our base. We know it's being raised to some power. And since we don't know what this is equal to, we don't know what its power is. So it'll be 8 raised to what power is equal to 32. Right? What I'm going to show you here now is something that you will need to be able to do in the future. All right? So don't sweat it too much right now, but it's something that you will need to be able to do this in the future. All right? Off to the side, let's just talk about something real quick. If I say 2 raised to the x power is equal to 2 cubed, what does x have to be? If they're the same base and are both being raised to a power and are equal to each other, well, that means the powers have to be equal. Because if x is anything other than 3 here, it's impossible for these two to be equal. So what we need to do for this is we need to manipulate our bases. We need to rewrite them as the same number raised to a power. And both of these can be written as 2 raised to a power. So 8 can be rewritten as 2 cubed. So all I did there is took 8 and rewrote it as 2 cubed. And 32 can be rewritten as 2 to the 5th power. And then our rule for power to a power is we multiply. So then I know 2 to the 3x power is equal to 2 to the 5th power. And since they have the same base, that means, and they're equal, that means that their powers must be equal to each other. So 3x is equal to 5. We can divide each side by 3. And that means x is equal to 5 over 3. So if you plug this into your calculator, 8 to the 5/3 power, you will see that it is equal to 32. All right, now this is something that we will do in more detail later on. That is the last thing for this video. What you need to be able to understand is that these two exponential equations and logarithms are inverses of each other, and you need to be able to rewrite one from exponential to logarithm and vice versa. All right, and then we'll use that later on to solve some questions. That's it for this video. We have 2 more.